All right, welcome back. Today we're going to start off by discussing uh, different ways that data can be spread out. These are just a few examples, so types of distributions, the way data can be spread out. The first type is what we call a skewed distribution. That's where we have a large concentration on one side, either the left or the right, usually. Uh, so that's where our mean is. But then the data spreads out far to the right in this case. And of course, it can be the other way where it can be a lot of data here and then skewed back the other way. Yeah, so skewed down like that. And that's one type. It's what we call a skewed distribution, where you have a large concentration on one side and then you still have some values, but they're much less as you go out to one direction, left or right. The second, I always remember the little kids song, Alice the Camel has two humps. Uh, and that's what a bimodal distribution is, where you actually have two high points, two peaks on the distribution. And of course, the valley could be much lower than what I've drawn in that first example, but where you have two peaks in the data, two areas where it's concentrated. And that's what's called a bimodal distribution. And then the third type, which is the one we're going to talk a little bit more about here in a moment, and actually what we're going to focus on in the whole next section, is where you have just the one peak and everything is symmetrical on both sides. So you have this smooth shape, which is sometimes called a bell shape, sometimes referred to as the bell curve, and that's this normal distribution. This normal distribution. And a lot of things, it turns out, in nature actually follow a, a normal distribution. Uh, One of the things I mentioned earlier were when you're looking at classifying children as far as their height, weight, uh, things like that are actually normally distributed. And then, of course, there's other possibilities as well. Uh, but the last one I want to mention is you could have something that's just completely chaotic, where there seems to be no rhyme nor reason uh, to it at all. We just can't find any rhyme or reason to it. Everything just seems to be random. And you might have a distribution that's something like this, a chaotic distribution, uh, where there's really just no rhyme or reason to it. Uh, Background noise, or in the old days when you used to unplug a TV from the cable, you'd have snow, right? Just the snow on there. That's a chaos pattern, a random pattern there. Uh, that would be an example of that. That's not something we're going to get into. Again, you may talk more about these other ones if you're in a regular statistics class. Now, we're going to focus on this normal distribution because one of the things we need to talk about briefly, at least, is this thing known as the empirical rule. The empirical rule for normal distributions. Okay, in a normal distribution. Okay. And it turns out that in any normal distribution, the following information is true. That if you're looking right here at the mean, smack dab in the middle here at 0, then and you go one standard deviation below and one standard deviation above the mean, that you would guarantee that 68% of the data falls in that range. In other words, falls in this area right here. 68% of the data will be right there within one standard deviation of the mean. The second one is that if you go two standard deviations out, so between 2 minus 2, 2 below the mean and 2 above, then you're going to get 95% of all your data values. And the final one is if you go as far as out as three standard deviations. Then for a lot of data sets, that's almost everything. Because 99.7% would mean that if you had 1,000 data values, 997 of them would be 997 would be inside three, and then only I'm sorry, I shaded that wrong. Would be within three, and only three of them would be outside. So you can see how many that really is. It's a lot. Okay, so that's called the normal distribution. That's called the normal distribution in the empirical rule. Now, your book might ask a few little questions about that if you're within one or another of these. So I wanted to point this out. We're not going to worry about this rule because this is kind of used as a ballpark quick estimate type rule. And we're going to have a better rule, a better tool in the next section. But I do need to at least briefly talk about this empirical rule. And so that's what I just wanted to kind of lay out very briefly there. So again, within one, it'd be 68%. If you cut it in half and you want it to go between the mean and one standard deviation, then you would cut that 68% in half, and it'd be just 34% there. The same thing if you went from 1 to 2, you'd cut the 95 in half. You get 47 and a half is within those two. And so that's the empirical rule. And like I said, you may encounter that a little bit in the homework, see it mentioned some, but that's what it means. But we're going to have a much better, more precise way of doing this so that we can actually talk about what percent falls within any standard deviation. Instead of one, what if it's 1.5? Or, what if it's between the mean and 1.5? Or what if it's just below 1? Not between -1 and 1, but what if it's everything below 1? All right, we're going to be able to answer those kind of questions in the next section.